Hello, hello. Yeah. Hello, YouTube. Today is day 5 of grinding low level design. For those of you who haven't seen any of the other videos before this, what I'm doing is basically I'm trying to build confidence in low level design by practicing questions, right? And I record the sessions and I post it on YouTube. So the first day what we had done is we had tried to come up with a framework, and this framework was basically used. I mean, the idea behind this framework was that there should be some sort of a mental algorithm that we follow, because during an interview it's going to be a timed interview, so we cannot spend a lot of time in understanding what steps are involved. So this framework we developed in the first video, and then we used this framework to make this blackjack game. In the second session we had tackled Stack Overflow and created this. Third one was library management system, and yesterday we had done LRU cache, right? So today is Sunday, and today we are going to do another question. I don't pick the questions in advance, so I'm just going to I go to this website, awesome low level, to this website, to this GitHub repository, and over here they have a set of problems. I just pick one and I get started with it. Let me just check if the mic is working fine. Hello, hello. Yeah, I think it's working fine. Okay, so today, which one should we do? We got interesting. I saw something called a coffee machine, coffee vending machine. What is this? Is this a what kind? Is this like a what kind of a low-level design is this? The coffee vending machine should support different types of coffee. Each coffee should have a specific price and recipe, ingredients, and their quantities. Okay, the machine should have a menu to display the available coffee options and their prices. The user should be able to select a coffee type and make a payment. The machine should dispense the selected coffee and provide change if necessary. Interesting. The machine should track the inventory of the ingredients and notify when they are running low. Okay, that's also interesting. The machine should handle multiple user requests concurrently and ensure thread safety. I think this last requirement, in the past couple of sessions, what I've seen is they just add in this requirement, and just in order to support this, all you have to do is use locks. So instead, like, I'll show you an example. For example, in LRU cache, did I use locks in LRU cache? One second. Yeah, so here instead of basically we have to wrap this code inside a lock, and that takes care of the last requirement. So, and that's true for pretty much every low level design question I've done. So in order to just have to support concurrency, we have to do like one or two things. The first one is to understand where that concurrency, where a problem can occur, which is usually when we access some sort of data. For example, in this library example, the books and members were the data, and whenever we do access books and members, we do it inside after acquiring a lock, right? And that basically that would give us the data concurrency. Yeah, so I think we're doing the same thing again and again. The last requirement doesn't really change much, but I like this question overall. I think it has some elements which weren't there in other questions. It has it has payments, it has ingredients. One thing I find interesting over here is, because we are also keeping track of the ingredients, it's possible that when a certain ingredient is low, suppose for example we ran out of milk, right? If we ran out of milk, the machine should still work with espresso, because espresso doesn't use milk. However, latte and cappuccino should stop working. Even, like, for example, if we are storing the milk capacity, we can even say that latte uses more milk than cappuccino, and it's possible that there might be possible, based on how we implement it, whether a latte can be disposed or a cappuccino. Like, it's possible that a cappuccino is possible at some point, but a latte isn't, if we are making it that specific. But we'll see what kind of design decisions we want to take. For now, I'm just going to copy this question and we are going to get into it. So I'm going to make a folder over here, coffee vending machine. Awesome. And in this, I'm going to create a file called question.txt. Okay, so we have our requirements over here, and let's start with our framework. So our framework says that we kind of have to go through the requirements and freeze the scope of the question, and post that we can start thinking about what kind of entities or classes there are going to be, and what variables will be housed in each of those classes, and what functions or methods will those classes support. And once we have mapped all of that out, then we can start implementing the code, where we have as there's no ambiguity in what is to be implemented. At that point, we start implementing the code. So we're going to start off by going through the requirements and freezing some of the requirements, trying to walk through what a real life situation would look like for a coffee vending machine, and maybe see if that's possible or not. So let's get going. Your coffee vending machine should support different types of coffee, such as espresso, cappuccino, and latte. I think that's fine. They basically need an option to get these three options: espresso, cappuccino, and latte. Fairly straightforward. Each type of coffee should have a specific price and recipe, ingredients, and their quantities. Okay. So if each of them has a recipe, what does that mean? She should be menu display. So if those ingredients are not present, well, in that scenario, the machine should not be able to make it, right? So effectively, it shouldn't show it in the first place, right? So when we are showing an option between what the machine can do, we have to take into consideration whether it's even possible to make that or not. Interesting. Plus, it is specified that ingredients and their quantity. So it's not like, for example, in an actual scenario, if you go to office and you see a coffee vending machine, you'll see like a bottle or a can of milk kept beside it, and there's usually a pipe which goes into that can, and basically at some point it takes milk from there, right? And at some point that milk gets over, and at that point the machine does not stop printing, does not stop you from getting a cappuccino, but rather, since there's no milk, it doesn't add milk to the cappuccino, and someone basically tells some guy working over there that, okay, can you just fill up the milk, and that guy comes and fills up the milk. But in this scenario, I don't think that works, because we also have to keep a tab of the quantities. So we are going to keep a tab of how much milk is left. So there is a situation possible where you could be getting a cappuccino but not a latte, because there isn't enough milk for one. Okay, so need an option to get either of these. Coffee should have, so okay, each type has a price and a recipe. That's great. Machine should have a menu to display available options. Okay, only available options to be displayed. User should be able to select a coffee type and make a payment. Payment should work. One interesting design consideration over here is, suppose we run out of milk. Do we want our machine to not even show an option of a cappuccino or latte, or do we want the machine to kind of show that option, but mark it with an asterisk, or if you try that option, it should give you some sort of an error saying that we're out of milk, basically? Because in one scenario, if you look at it from the customer's point of view, in the first scenario, if it's a new customer, they wouldn't even know that the machine supports cappuccino and latte, right? In the other scenario, they would kind of understand that, okay, this machine does support cappuccino and latte, but it doesn't have any milk at the point. So maybe the customer would contact someone, or maybe you will keep some sort of a phone number on the machine saying that okay, if you face this error or if this happens, maybe press a button or lodge a complaint or talk to someone. So definitely a design consideration, a product consideration, what to do over here. I feel it should kind of just give an error, but then again there is a there is a payment being done, so it's not that easy. For example, if you picked cappuccino and the machine knows that there's no milk over there, it should not take the payment as well, right? So before the payment it should kind of give some sort of an error saying that the milk is not there, but the machine does support cappuccino. I think that makes sense. We don't want users to come to the machine and not even find out that you can get a cappuccino over there. So I think that makes sense. So the payment should work, and only available, so this is wrong, right? So the requirements is that all options to be displayed, but show error if if cannot be made, right? If it cannot be made. So fine. What else? So we have the machine should dispense the selected coffee and provide change if necessary, or it should also give change. One interesting thing over here is the type of change you can give, right? So we can say that, how does giving change even work? For example, you give a 100 rupee note, and there's some, if the coffee was for 80 rupees, you have to give back 20 rupees. But how does giving back that 20 rupee work? Like is it in coins? Is it in notes? I think it depends on the machine itself. So early on in my career, I did intern at a food vending machine. Over there, we faced a similar problem. We didn't implement this ourselves, that how much change should get dispensed. There were APIs which like the machine came with a set of APIs, and we just had to call the API effectively. But it was such a big hassle to send someone to the machine every single day to fill it up with coins. It was such a big hassle that we just decided to switch to digital payment. I think so. In digital payment, you don't get any of these hassles, right? So you have to consider where you're installing this coffee vending machine, and the people who are going to use this coffee vending machine, are they more likely to have a digital form of would they prefer a digital form of payment, or would they want to pay via coins and cash, right? So since that context is not given, maybe we can just choose a context and get it over with. Let's just support digital payments. Let's remove this dispense the selected coffee and provide change if necessary, because I don't think we should go into that much detail saying that okay, 5 coins of 5 and 10 coins of 1 rupee should come out, and then keep track of how many coins there are. So if you're not doing that, then providing change is not really that big of a challenge. So let's just skip it, right? So we'll assume that the user always pays the exact amount. The machine should track the inventory of ingredients and notify when they're running low. This we should do. Notify when we are running low. Who should they notify when we are running low? So one form of notification is definitely when we are doing that. For example, when someone buys a cappuccino and there's no milk, we do notify the customer on the coffee vending machine itself that the milk is low. The other form of notification would be to management, where it might call an API, send an email or something to whoever manages that whoever is responsible to fill that coffee machine with milk. So I think both of those can be done, right? So the machine should handle multiple user requests. This, as I said, that we just have to use a lock for this. So I'm not too keen on adding that lock implementation in every single code that we're doing, because frankly speaking, it's not that big of a deal. We're just identifying the critical section in the code and we're just wrapping it inside a lock. So I think this is good. We need to notify management of ingredients we are running low on. Okay, so let's think about the entities. The next step is, now that we have closed our requirements and closed the basic scope of our problem, let's think about what kind of entities are they going to be. We have a vending machine, of course, right? Vending machine class. And what else? What all are we gonna have? We're gonna, does espresso, cappuccino, latte use the same ingredients? Interesting, right? We do need to store the ingredients and the quantity per ingredient for each of these. So we need to find a way to do that. So we have, well, to be honest, espresso, cappuccino, latte are all forms of drinks in a way. So maybe we can keep a drink class, right? And the drink class, let's keep a map of ingredients to quantity. I guess it makes sense to have a map of ingredient to quantity in the drink class. It also maybe has a name. I mean, this is a generic drink. We're gonna kind of give it a name once we extend espresso, cappuccino, and latte, maybe. Or what else can we do over here? Since we are supporting just these three, we can even store just 3 instances, but I'm feeling like later if we want to add another type of beverage, we should kind of support that as well. So let's think about it for a second. We have so to our coffee machine, it would just consider that a beverage, right? Beverage, right? Our vending machine, let's just call it coffee machine, and this is our beverage. So to our coffee machine, we just have a list of basically beverages which it supports, and it kind of needs to know how much quantity of what ingredient is required by that specific beverage. It needs to know the name of the beverage. Right, string, this is a dictionary, right? Ingredient to quantity, beverage, and then for each beverage we can probably modify this. Like for example, we can have an espresso beverage, espresso class, or maybe when we create a beverage, we kind of just pass in these things to when we are creating the beverage, right? Because the espresso, cappuccino, and latte are basically just beverages, right? So yeah, so we have a beverage which contains ingredient to quantity. This would have all the ingredients of the coffee machine, and the quantity would basically show how much of that ingredient is needed. We have a name. We probably should have a price, right? So from this class we can create an espresso, cappuccino, and latte. Yeah, and then basically the coffee machine needs to, either we add it initially already, like these beverages can be added, or we provide a function called add beverage, which takes in a beverage object and basically just adds it to the coffee machine menu. But in this case, I guess that we don't really need to support that, so maybe we'll just add it in the variables itself. So the coffee machine, we kind of know that it's gonna be, we're gonna have a, so how are we gonna do this, right? Because how will the user interact with the coffee machine? The user will be provided an option, so the coffee machine kind of has to print available options probably, right? And this available options are essentially all the options that the coffee machine has. So there's no so after that, after printing this, the user can dispense beverage function. Actually, let's see, we have a payment gateway, let's even create a payment gateway. Let's create a, so we do have a coffee machine with available options. Dispense beverage. I'm wondering whether we should kind of abstract out the coffee machine and keep two classes, one for managing the ingredients and the coffee and everything, and one just to interface with the user. Because it kind of feels like this class is doing a lot of different things which should not be coupled together, right? On one side it's interacting with the user and it's interacting with the payment gateway, and on the other side it's also sort of managing the inventory. So maybe we'll keep a inventory manager as a separate class, right? And we'll keep a coffee machine, which probably won't have a lot to do with inventory, but the inventory manager will handle checking if there is enough ingredients, can we even dispense this, and coffee machine is going to probably handle the general flow of how the user will interact, right? And we have a payment gateway. We kind of also need a notification service, right? And let's just call it payment service. Gateway could mean a couple of things. Coffee machine, inventory service. Let's just call it inventory service, keep it consistent. And we have a beverage which would have some ingredients to some quantities. So how do we want to do this, right? So when we talk about, let's do the easiest first. Notification service would support send notification function, which takes in what do we need to notify again? We need to notify, let's just notify the current inventory status, probably inventory, right? Inventory status it needs to notify, or do we just need to send a notify when of the things that are low? For example, if we are kind of running low on milk, should we just say that the milk is this much and it's running low, or should we just send the entire inventory so that when they're filling up the milk they can also kind of see if there are other items which will become low in the future, like in a couple of days, and they can fill those up as well. I think it makes sense to send the entire inventory status, right? So yeah, the notification service will have a send notification function, and the notification service should not really care about what notification is being sent. I don't think the notification service really needs to know which service is there and what is there. I think it makes sense to just keep it simple over here and just take a message, right? So send notification just takes in a message and sends that notification. The creation of this message we can handle somewhere else. Right, so we get a payment service. The payment service, so the user comes, he selects an option, he looks at the price, he, I guess, make payment function. And the make payment, what does the make payment need? It kind of needs the amount. Does it need the user information as well? And so the destination is pretty much the same, but the source could be different based on which user made the payment. So we probably need the amount. I guess we need the user as well. Maybe in the form of a user ID at max, right? Just so we have it in the logs, which is of type int. So let's just create another simple class called user, and the user would, let's just give it a name, string, and give it ID of int. That's pretty much it. We're going to keep the user simple, and then the user ID will be passed to payment service, and they can make a payment. And for now, let's just say the payment is always successful. It's just a happy path. Usually what happens is the payment can fail, and there are usually multiple different checkpoints of where the payment can fail. For example, if you've enabled payment through some partner or some other company, maybe GPay, maybe Amazon Pay, maybe whatever, like some other company. You're gonna send them a notification saying that okay, this payment is being made, and then their services send you some sort of a acknowledgement that okay, this payment got made. So if like since there are so many moving parts in this, there can be a lot of different kind of errors. But for now, let's keep it simple. Make payment always succeeds. Let's assume 100% availability for all our services. So yeah, make payment will work. Then we have our inventory service, I guess, and the coffee machine. What does the coffee machine need to do really? The coffee machine needs to have a function called print options, probably, right? Print options doesn't take anything, it just prints the options. It needs to house the options as well. Does it need to yeah, the coffee machine needs to know what all can be can be dispensed at least. So how should we keep it, right? How should we keep it? For example, the user chooses something, then the coffee machine, okay, in the user flow, what's going to happen is the user is going to say print options. There's going to be a list of options which will have espresso, cappuccino, and latte, which we can even hard code for now, or maybe we'll keep it as a list inside this, right? Options as some sort of a list of strings, right? And suppose the user kind of picked one option, what happens then? At that point we probably need to check with the inventory service whether it's possible or not. Is are ingredients available function maybe, and this gives in that particular option. And what the inventory service effectively needs to do is it needs to check whether we have enough resources. So it's gonna definitely have a map of ingredients, right? Did I spell that right? Ingredients. So it's map from ingredients to quantity, right? So are ingredients available? You get an option. We also need to know the ingredients and the quantity required for that particular option. So it probably needs to have another map of recipe, and the recipe can be the option itself. So let's just instead of options, recipes, print, let's just call it recipes everywhere so that we don't get confused. Recipe. So are ingredients available for this particular recipe? It's going to check the map of recipe to for each recipe it would kind of need to store what ingredients and by how much quantity is needed. Oh man, that looks like a 1 second. Why I'm hesitating over here is because I feel like there'll be a lot of redundancy in our system suddenly, right? Because if the recipe, if 3 of the recipes need milk, do we really want to store 3 variables of milk? Let's see. Why is this not working? Online whiteboard. Just any online whiteboard would do. Yeah, so what I'm saying is, suppose we have first is espresso, and this kind of needs water, and it needs what else does it need? It needs coffee. Let's just say it needs coffee. And then we have a cappuccino, right? Cappuccino. And cappuccino would also need water, it would need coffee, it would need milk, right? And then you would have another one which would need other things as well. So maybe it just makes sense to keep it as a graph, right? We'll have nodes which represent ingredients, and then we would have these espresso, cappuccino or something which can basically point to the nodes that they want. And this graph can even be weighted, like the weight on the, what do you call, the arrows which point to which ingredient they need, that can just represent which ingredient is needed, right? That ways at least we won't have redundancy in these variables. And later on, if there is, if we get into some complicated stuff where each of these is also built with other stuff, which in this case probably is not going to happen, but it's, you can imagine that, espresso uses milk, and suppose in the future we kind of decide that milk will get now created with water and milk powder, and then you start creating milk powder with other stuff which gets used by other components as well. Yeah, I think the graph way is definitely the way to go in a more complex scenario, because it kind of will it even be faster? 1 second. So what were we trying to do? For a particular recipe, we wanted to check for each ingredient and quantity, right? We wanted to check for each recipe, we wanted to check ingredients and quantities. So for each recipe, yeah, it would just check those ingredients, right? We would have references to these, and then it would take the same time. Oh, it might take the same time though. Even if you store it in sort of like a list, it'll just go through the list. So yeah, this is you can imagine that the space complexity would be a little higher if we don't do it in a graph, but the time complexity I feel is sort of similar, only because in this, like at least in this simpler scenario where we have one level of ingredients, I think I'm okay with just keeping it as a list. But if the question was framed a little bit different, for example, if the question wasn't that we want to make a coffee machine, but rather suddenly you say that we're making a smart kitchen, right? That could be an interesting question. You could say that we are making a smart kitchen, and we want that kitchen to be completely autonomous, and we have a smart fridge, we have smart storage, and in that case, when we actually store the inventory, it would make sense to keep it in a sort of like a graph structure, because suddenly then you would have stuff like bread, right, which can be made from probably water, salt, and wheat, right? Whole wheat? No, not whole wheat. And then suddenly some other ingredient, you would say pasta, also kind of takes in salt, it takes in wheat, but it would be maybe a little different. It would maybe take a mixture of maida and something else, right? And so yeah, so I think in that kind of a scenario where we would have like a smart kitchen with multiple levels of ingredients, maybe it makes sense to have this sort of like a graph data structure, right? And then if you want the actual ingredients, and then we can even store just the last layer, right? Like for example, if you want to check if this thing is possible, if bread is possible to be made, like if this item is possible to be made, and suppose this is just something that uses bread, so maybe it's a sandwich, we in the inventory we just store the last layer, and then for sandwich we can just traverse this tree and get the leaf nodes, and basically that's what we're going to check. But I think we got away from our question a little bit but yeah, it's a good example to have. I think it's quite plausible that some interviewer might decide to say that, okay, this coffee vending machine question is there on the internet, but if we just change it up into a smart fridge sort of question, I think it's an interesting question to ask in an interview. Anyways, for now I think we've decided that we're gonna keep a map from recipe to a list, probably. List of what? We can keep a list of tuples, and each tuple would have two elements. The first element would be the ingredient, and the second element would be the quantity, because when the user comes, he prints the recipes. After that, what happens? He selects a recipe. The coffee machine is get recipe. Let's just call it get recipe. So the user would call get recipe. Internally, get recipe would end up calling our ingredients available from the inventory service, which we do need a inventory service object over here, right? Inventory object over here of type inventory service. To be honest, when we talk about design principles, like solid design principles, I think one of the principles is that we should kind of not couple these classes together, and instead of having an inventory service over here, maybe it would make sense to have an inventory service interface, right? And then and that interface would probably be implemented by this inventory service, and then we basically have an object of this inventory service interface. That way we can swap out our inventory service whenever we want to, as long as it satisfies the interface. So are ingredients available? It checks if ingredients are available. If they aren't available, it shows some sort of a response to the user. If they are available, then it's going to, what is it going to do? It's going to defer to the payment service, probably, to make a payment. Maybe the payment can just take an OTP or something like that, and then if the ingredients aren't available, it will also probably send a notification. Otherwise, it will make the payment and it will just dispense it, I guess. It'll just dispense it, and even we have to update the inventory service, right? We have to update, because now that we've actually dispensed it, kind of makes sense to update this. We can have an internal function here called dispense recipe as well, and this can internally sort of call update inventory with the recipe, and we're assuming the coffee machine works one recipe at a time, so I think it should make sense. Okay, I think we have everything, right? How are we handling the... Yeah, then this beverage is not needed, I guess. The inventory service is kind of storing the ingredients and the quantity of each ingredient inside a map anyways, so I think we're good. So let's do one thing. Let's start coding. Let's create a new file called main.py, and let's take this list of questions to the side. Okay, so let's start with the easiest class first, which is the user class, and let's define our constructor. Probably take a name of type string and an ID. Maybe we can just generate the ID, so we'll say ID is equal to 1, and over here let's do self.name is equal to name, and self.id is equal to user.id, and let's probably increment the ID. So this ID variable is actually tightly coupled to the class and not objects of the class. So when I do user.id, it takes in 1, and then I update that. So the next time I create an object of this class, the ID would actually be 2. So that's why this kind of code would work out. Let's also modify the toString function, and let's just modify it to return the name, self.name. Maybe you can self.name, maybe self.id as well. Probably it's an integer, so we'll have to change it to the string representation, and we just add some sort of a delimiter so that we know that this was before the name, right? um, I think this is fine. So we get ID and name. So we have done our user class. Then we have our notification service, right? When we write our notification service, how do we plan to write it? Let's create an initializer, which is probably, does it really have much, the initializer? What are we initializing the notification service with? Honestly, the notification service will also be calling sort of get this send notification. So an argument can be made that when we have a notification object over here, that should be of type notification service interface. I mean, just so we don't have objects over there, right? So we can, and I think it'll be interesting to even learn about interfaces. I'm not 100% sure how interfaces used to work in Python. Annotation. Let's see. In Python, how can I create an interface and then another class which implements it? I mean, I know about parent classes and child classes, but interface is something interesting, right? Okay, so ABC, is this really the name of the module? Abstract base classes. Oh, that's interesting. From ABC import ABC and abstract method, and then you define an interface, my interface, and you pass it. Oh, it's just a child class effectively, and then you define these abstract methods over here, and then later on we can probably define import that interface, which in our case we're just doing it on the same file, and then this class would implement that interface. Interesting. So yeah, I think we should use this. Let's go ahead and use this then. Let's copy the code. Let's come over here. We need to, so we actually needed two interfaces, right? If I understand, the first one was our notification service interface, right, which takes an ABC, and it had one abstract method which is send notification, and send notification does take in a parameter called message, which is of type string, right? And then we also define another interface called as the inventory service interface, and that has a couple of things, right? Are ingredients available, which takes in recipe, and recipe at this point is just a string, right? Honestly, I don't think it makes sense for the recipe to be a string. Let's keep it as an enum instead, because we kind of know what all recipes we have. So we I kind of forgot how enum works. Actually, I had implemented that in a previous, probably implemented it in a previous question. So I'm just gonna look it up. Enum, right? Oh, it's not there in this one. Maybe in Blackjack. Enum, yeah. So great. So now we can define recipe as an enum, which is rather interesting, I feel. And then we can add our whatever coffee we wanted, which is espresso cappuccino and latte. Okay, great. So we have our recipe. I mean, does it need to be okay? It can be. How are we referencing enum again? User. Yeah. Okay, let's keep R as small. Oh, why did it? Is the caps lock on? Yeah. Okay, so we got our enum, which is a recipe, which we get recipe here now, right? So are ingredients available? Yeah. We take a recipe and we check whether the ingredients are available. This will get printed out, whatever, get implemented later on. The second abstract method, update inventory. And update inventory, the recipe, right? It still just needs the recipe because this is the recipe which is being dispensed. Nice. So we have our inventory service interface and our notification service interface. And now instead of writing the notification service first, now we can safely... Oh, do we even need a payment service interface? I guess that makes sense, right? To keep another interface called payment service. You know, although it kind of looks like bad, it kind of feels like a bad coding practice because I mean, from the surface it kind of looks like that because we're creating 3 interfaces and then we're creating 3 classes which implement those interfaces. But in reality, when we're working with larger projects, it's always better to follow the design patterns and implement it like this, simply because you don't know what's going to happen in the future. Like for example, right now, you know, in a real sense, suppose we did Paytm's payment service and we implemented it as a class, coupled it tightly with the coffee machine code, and then later on, you know, we decide that, you know, we want to change our payment service suddenly, right? We want to change our payment service, we want to use some other payment service. So we're going to have to actually modify the coffee machine code in order to do that. But if we were using interfaces, we could have just created another class which implements that interface and then swapped it out. So I think it makes sense to keep these interfaces for sure. So even though it kind of feels like, if you've not worked in a company on a big project where, you know, there are like 100, 200, 250 developers working on the same code base, and, you know, the project, even the product has been going on for years, you might kind of just feel like, you know, this is just this won't be used in the industry. But definitely it is. It'll like, it's always better to write code as per taking into like good principles, good design principles. So let's do the payment service interface. It has a make payment function, and let's take in a user ID which is of type integer, right? And the amount which is again of type integer. Awesome. So we have our notification service interface, payment and inventory interface, and let's just start off with our coffee machine, and later on we are going to implement these interfaces somewhere and use those objects instead. So let's do our constructor. Let me just, sorry, I was just checking whether it's recording or not. It would be a big fail for me if I realized that I hadn't pressed the record button. Anyways, so it's a coffee machine. Coffee machine takes in, what does it need to store? It needs to store, oh, 1 second, the inventory. Oh, it's an interface, right? It doesn't need, okay, when we implement it, we are gonna keep it over there. Okay, fine. So we have a coffee machine. Coffee machine takes in what? It keeps a list of recipes, which sort of makes sense. Let's call it recipes, which is a basically, so this is not a string anymore. This is enum now, right? So does the user pass in these recipes? The user definitely does not pass in these recipes. So we are going to just do self dot recipes as a list of enums. Can we just directly do that? Python initialize a string, sorry, a list of strings. Yeah, we can do that. So this is your enums. So recipe dot, we got a cappuccino, we got a recipe dot espresso, we got a recipe dot latte, right? So we got these, basically got these 3 things in our recipes, because the user does not pass these. We had an inventory object, we had a notification object, right? And these were needed. So what do we do over here, right? We need a self dot inventory service. I mean, either we can plug it in here itself, right? Either we just plug it in here, or we create and pass it. Unfortunately, no, I think we'll just create it over here, and but then this won't get used, unfortunately, right? The inventory service, yeah, because we're not defining a type for inventory service. Ideally, maybe if we had defined some sort of a type and then pass that type, it would have worked. But in this scenario, unfortunately, it kind of feels like because what's going to happen is we're going to implement this payment interface service or whatever, and then finally just implement it as another class, and then create an object of that class over here, which is sort of unfortunate since we're not passing it in the constructor itself. What can we do here? Maybe we can set it up somewhere, right? So dot we get, what else do we have? We needed a inventory service, we needed a payment service is equal to none. Let's initialize it to none, and then we had a inventory payment and notification, right? Notification service, which is also, I guess, none. And then we can call set inventory service, right, at some point, and that will basically take in a inventory service interface. Does that work? Will that work? It's equal to object, right? And then we can basically set these things. Wait, what was not closed? Oh. Did I not close this? Wait, what's the problem over here? Set inventory service, it's part of the coffee machine. It takes in a it is closed, right? Why is it not letting me define this set inventory service method? Am I missing something here? That's how we used to define methods, right? In class we just say, yeah. What is it, because of this interface? Huh. Because it's not able to identify this interface. Python, how to pass an interface. Oh, my bad. That was my bad. Oh, I think that was just... Yeah, I think this works now. Set inventory service. We would have our set payment service. notification service. Yeah, and then we just set it to that object, and then we could basically, these three need to be called at some point to set our interfaces. Initially they would be none. Right, maybe we can define set objects, something like that. And this would maybe just create the objects and set them, and then we basically won't be expecting that particular class over here. We would be, inventory service would be of type inventory service interface. Right, set objects, that's, yeah, we'll create it later. Anyways, so we have our inventory service, payment service, notification service. We have these methods. What else does our coffee machine need? Def print recipes. Okay, it already had recipes. So for each recipe in self dot recipes. Okay, just print out the recipe. What else? We have a get recipe function, right? And this needs to do a couple of things, right? It needs to first check if ingredients are available. You know, let's just do this in get recipe only. We check if ingredients are available. How do we do this? We call self dot inventory service dot are ingredients available, and get recipe would take a recipe object, right? Yeah, it would take a recipe of type recipe, right? Or is like enum dot recipe or something, or we can just use recipe. I guess we can just use it, and then we just pass in the recipe over here, our ingredients. So if not of this, so if ingredients are not available, let's say we want to print ingredients are not available, and also we can do self dot notification service dot send notification. We needed to send a message, right? So let's message is equal to please fill the following ingredients, right? And then for but we don't know, right? So are ingredients available is just saying whether they are or they aren't. It's not really telling which ingredients are not available. Maybe we need a way to get the inventory as well, right? So so that we can at least add the inventory. So for the inventory service interface, let's define another function, to be honest, and let's call it get inventory, right? And get inventory just passes back this map of ingredients to quantity. So we take that map essentially, right? We gonna take the inventory self dot inventory service dot get inventory. We got our inventory object, and what happens when we convert dictionary to a string in Python? Can we even do that? And you can typically strings represent key value pairs. Yeah, so it's just gonna give the key value pairs, which makes sense, right? So yeah, this works. Let's ingredients are not available, and the inventory service would basically get the entire inventory and say give the inventory. And also let's edit that user requested, right? And user requested, what did the user request? He requested a particular recipe. One second, it's the variable recipe, right? Probably string representation of that. And then you have another delimiter, maybe this, and say current inventory. And it's just gonna, so basically it's gonna tell that okay, this item, this recipe is, you know, is not being dispensed, the user requested this, and the current inventory is this. Whenever the notification is sent, the understanding is that it's probably some problem, or you know, some inventory needs to be filled up. Okay, so we have check if ingredients are available. If our ingredients are available, turns false. We do this. If ingredients are available, then we kind of need to firstly, I think we need to remove it. We need to take payment as well, right? Yeah, so we do self dot payment service dot make payment. So let this make payment. Then we do self dot inventory service dot update inventory. We pass in the recipe. Yeah, and I think it is, we can print out dispensing and you know the recipe. Okay, so looks like this is done. I hope so. We still haven't set our objects, we still haven't implemented these abstractions. Class my notification service, let's call it my notification service. And how did we implement abstract classes? So in my class you take in my interface and implement it. Awesome. So you take in my interface and then you implement it. Of course we're gonna give a, I think for notification service, do we really need a constructor? There's really nothing to be saved here. So we are just going to define the send notification function, which you know usually would send out an email or something like that, but you know in this case it doesn't do much. So it does take a message. It does take a message of type string, and it just prints it out. Print out sending notification, and you know the content of the notification to be sent over here, right? And once we do this, my notification service needs to be over here, right? So we need to do self dot notification service is equal to my notification service. We create that, right? And similar to this, we would also have an inventory service. We would also have a payment service, and let's just name them my inventory service, right? And my payment service, right? Although these, you know, I haven't defined these, but I will. So notification service is done. Payment service, let's create class my payment service. Okay, so it takes in the payment service interface. Again, we don't really need to save anything as such, so we just implement a make payment function, and let's print out making payment. You know, it takes an amount and a user ID, which we did not account for when we were actually doing it, right? We did make payment, but it needs an amount and a user ID, right? Yeah, so the coffee machine at least needs to know the amount, unfortunately. Yeah, maybe it makes sense to make these into tuples and say this is 50, the espresso is 40, and then the latte is maybe it's 60, right? Whatever. Are we using self.recipes anywhere? Oh, just to print recipes. That's fine. So we do take a recipe object. Oh, we need to go and check, right? Oh man, maybe okay, for now I think let's just create a create a price map over here, right? And we say that, you know, this is worth 50, and we say that this is worth 30, and the recipe dot latte is worth 40. Okay, and then we can just pick it up from the price map. Yeah, so this would take a price map, recipe, and this won't be self.price map. I think it will still work with self.price map, but let's just do coffee machine dot price map, and it takes in user. Actually, I think let's just let go of the user object for now. Payment service, let's remove the user ID, because we're not even passing the user ID anywhere, right? Get recipe. At this point, do we really need a user ID? Maybe the payment service should handle all of that. So let's remove the user ID from here, and even from here for that matter. Making payments of amount, right? And we nice. So we just assume that the payment was made over here. And last but quite definitely not the least, we have our my inventory service. I think that's about it, right? And this probably take in this, and it does store a couple of things, right? Okay, so let's see, let's define our constructor. We just hard code it. Yeah, we'll just hard code it, right? So self dot, what do you want to call it? Inventory is equal to a map. So we need two maps, right? One for a recipe to quantity, and a inventory map and a recipe map are fine. So inventory map would take the basically ingredient to quantity. For now we just have, you know, a couple of ingredients, right? We have milk, let's say we have 100 of this. Let's say we have water, which is again 100. Let's start everything with 100, and coffee again 100 of this, right? And then we have self dot recipe. Let's just call it recipe map so that there's no confusion. Inventory map and recipe map. Recipe ingredient map. Okay, so now we have our recipe dot cappuccino. Why is this represented as a list? Anyways, oh, so it's basically what would this take in how much quantity? Okay. So for example, it would take milk. How much milk would a so the other one was water, and the last one was probably coffee, right? And it would probably be a little bit different for cappuccino and espresso and latte. Espresso, and let's change this to latte. Espresso, I know that it doesn't use any milk. It does use, let's say it's 50, not 50 water, let's say it's 40 water and it's 40 coffee, right? And for latte, let's say it is, you know, it uses a little bit less coffee. Maybe this coffee, it takes a lot of milk. Let's do 60. And water, maybe 0, it doesn't use a lot of water. And let's say this guy doesn't use water, it uses some milk, less than the latte, and it takes a little bit more coffee. So we got this ingredient map, and then we would have to define some functions, right? These 3 functions. Okay, so let's ingredient list is equal to self dot recipe ingredient map, pass in the recipe. So we got the ingredient list, and then for each ingredient tuple in ingredient list we have to check, right? So at any point, if the quantity is equal to what? The second, and the ingredient is equal to the first, and we check, right? If inventory, if self dot entry should show me inventory map, right? Yeah, inventory for this quantity is small. If that is actually smaller than the quantity, then you return false, right? And if I used ingredient, we use quantity here, and if this entire loop completes without the return of false, then we just return true. So this function is done. Then we have update inventory function. At this point we are sure that the the items are available actually. So, and we are given a recipe. For this recipe we need to find out the ingredient list. Then we have to, for each of these, so a lot of the code is the same actually. Maybe it makes sense to take it out into a common function or something like that, but for now we are just going to do this. Self dot ingredient is negative equal to the quantity, right? So the inventory gets updated, and this is the easiest function where we just return self dot inventory map. Okay, so I think the my inventory service has been implemented now. Is there anything else left? Not really. I think we just need to check out the code. So we take in a, let's call it a CM is the coffee machine. I don't think it takes anything in the constructor, does it? No. Okay, and we do CM dot price map recipes. I wouldn't call it recipes, right? Maybe it's something else. Print recipes. Yeah, that's what I'm wondering. Why would I call a function recipes? print recipes, and then we probably need to take user input, right? Python, how to take user input. I think it was the input function or something. Yeah, input function. So we have a user input over here, and this is not enter name, this is enter a recipe, right? User input. And then what do? We call cm dot get recipe, and we pass in the user input. So get recipe expects a string, right? Oh, it's a recipe. That's unfortunate. Ideally it should be, oh god, okay, 1 second. So this is a string, so this is the user recipe, right? And then we have another recipe which we need to set to a recipe. So if the user recipe is equal to E for espresso, then we just set this to recipe dot. Wait, why did this not work? Oh, because it's counting this variable, right? I think that was an oversight by on my part, but man, it's okay. Let's move forward. Wait, this should have sort of worked, right? Cappuccino. Yeah, we can just do else. To recipe dot latte. Finally, so then we use that, right? So we take the user input, get recipe. I think that's about it, right? We'll just make the payment, and I guess it'll just do everything itself. Kind of put this in a while loop. Maybe input, press enter to continue, and let's just, maybe we should print out the inventory for check, right? Dot inventory service dot get inventory. Nice. So we print out the inventory at this point. Print statement over here. Inventory. Okay. And after doing this, let's wrap this in a infinite while loop. Oh, that took some time. I'm sorry, where were we again? Coffee vending machine, right? Yeah, main dot second python main. Okay, so our code started, our coffee machine started, and it printed out a cappuccino, an espresso, and a latte. And we have to, what do we have to press? E, C, or L, right? Yeah. So we do, suppose we do a espresso, so we do a E, right? And we press enter, and there's some sort of a problem. Are ingredients available? Runtime object has no attribute are ingredients available, unfortunately, which happens on line 123. So 123, are ingredients available? Inventory service object does not exist, unfortunately. Did we not call set objects? Yeah, I guess we did not. So we kind of need to call set objects. What ended up happening is that since Said object was not called. The notification service, inventory service, and payment service were completely empty, right? Hey, 1 second. I did not. I should have. Why didn't I call? Oh, I didn't. I think I made a mistake over here. Unfortunately, I should be calling self.set inventory service and just passing an object of my inventory service. In fact, I don't have to actually set the inventory service over here, right? I just have to call set an inventory service similar to the payment service. Like this, similar to the notification service probably. So set notification service. Let's look it up. And yeah, so let's do espresso. Okay, so something happened. So we let's see if it even worked fine or not. We started with when we talk about our inventory, started with an inventory of 100, 100, 100, right? And we said we needed an espresso. So when we took an espresso, it's just 40 water and 40 coffee. So we have 160 water and 60 coffee. So we were able to dispense an espresso. So let's do one thing. Let's keep dispensing an espresso till we run into an issue. Right, so we take espresso again, and it worked out again, but just water is at 20, coffee is at 20. But now the problem is when I do espresso, this shouldn't work. What it should do, however, is tell me that ingredients are not available, and it should send out a notification. Boom. And yeah, that failed. Bad operand type for unary plus a string. Oh, there's a comma over here. That's the problem. In line 127. 127, 127. Wait, what? 127? Send notification. Oh, over here, send notification, right? So when we do a send notification, we just send out a message, right? Yeah. I think I added that comma by mistake. Anyways, let's try it out again. Okay, so we got our espresso 1 going once, espresso twice, and now this should cause an issue. Correct, right? Ingredients are not available. Sending notification, user requested espresso, current inventory under 2020, dispensing recipe. Oh, it still dispensed it. Yeah, it should not have dispensed it. It printed ingredients are not available. Making payment amount. Oh, 1 second, it just did everything. It dispensed it also somehow. That would have caused like great issues, right? Because the inventory would go into negative. Yeah, it did. Water and coffee went negative. So unfortunately, there is definitely a problem over here somewhere. Ingredient not available. Why did? Oh, okay. We did not. Yeah, we probably have to return over here. Let's try it another time. Okay, so we do espresso, we do espresso, and then we do espresso, and it says ingredients are not available, sending notification, user requested espresso, and the current inventory is 20, and the inventory is still 120. So this works. Unfortunately, nothing can get expensed now, right? If I do C, the same thing will happen. If I do L, the same thing will not happen. Wait. Oh, it was able to do the latte, right? Oh, did the latte use like 20 coffee? Did the latte use 20 coffee? Oh, it did, yeah. So okay, so the latte works. This time if I do the latte again, it's gonna fail, right? Yeah, ingredients are not available, sending notification. Oh man, okay. Let's just cross check the price once. When we took the latte, it was 40 rupees, right? And the latte was in fact 1 second, where did we keep the price? Yeah, latte was 40 rupees, and when we did enter L, it was 40. When we were doing espresso over here, it was 30. Yeah, you should probably just check cappuccino once. Yeah, that works. Oh man, finally we were able to do this one. This was an interesting exercise though. This one was, I found this one to be more interesting than the others, except for maybe LRU Cash. LRU Cash was pretty interesting, but coffee vending machine also I would say is good. Like I think if you want to practice, creating interfaces, you want to practice proper entity recognition and identifying which classes should be there. I think this is a good question to solve because while noting down the scope of the requirements, we have to kind of come up with this sort of a system where we segregate the inventory service from the coffee machine and the payment service and the notification service. In all the other questions it was much simpler. It was just like one or two very obvious classes, but in this one it was a little bit more than that. But yeah, until next time.